Guys, this is our second video for calculus. We've got another set of examples I want to do. We are doing limits, and I've got 4, 5 right there, and I've got 6 and 7 right there. So let's jump in to number 4. Okay, so basically the rule is if you can plug in whatever it is you're plugging in, then plug it in and that's your limit. If you can't plug it in, then you've got to do something first. You've got to see if you can simplify the expression or simplify the function, put it in a different format or something to see if that'll work. And so that's what we're going to do. Now this first one looks very strange. It's got something raised to the 50th power, which is something you're not normally used to looking at. And so what we're going to want to do for this example 4 is we're actually going to factor it. And what I'm going to do is on that numerator, I'm going to factor that numerator out. And this is very different, but it's x minus b to the 50th power minus 1 times x minus b. Okay, so look at that. I factored out a negative 1 from that expression right there. And so now this represents a common factor. This is similar to factoring by grouping, something you may or may not remember, but it is factoring. So if I take x minus b out, remember when you factor, when you would subtract an exponent. So then that's going to leave an x minus b to the 49 minus 1. And that's what I get when I factor out an x minus b. And that's over x minus b. So think that through. It's very tricky. That's going to cancel out. And so my simplified function is that. And so now I want to do the limit as x goes to b of that. And so that's going to give me b minus b to the 49th power minus 1. Well, that's 0 minus 1, which is just negative 1. So my limit is just going to be negative 1 for this one. X goes to b, not x minus b. So this little factoring, you're factoring out the parentheses. Okay, just be real careful dealing with that. All right, so now example 5, we've got a radical. All right, so now example 4, we used factoring. That's one of our strategies. And whenever we have a radical, our first strategy is going to be to rationalize. Now, rationalizing is one way of doing this. There is another way that actually uses some factoring that you may or may not ever been taught or ever been seen. It doesn't show up very often, but it works. And so it is an option. So I might do it both ways. So let's rationalize first. So if I rationalize this function, I'm going to rationalize the numerator. And this is not something we normally do in pre-cal. We normally rationalize denominators. But in calculus, we'll rationalize numerators as well. So I'm going to multiply top and bottom of this fraction by the square root of x plus 3. It's going to require FOIL on both parts. And so I'm going to be looking at the limit as x goes to 9. I keep losing my arrow. And then I'm going to FOIL at the top. And that's going to give me the square root of x times the square root of x is x. And then I'm going to get plus 3 square roots of x minus 3 square roots of x. Of course, that goes away. Minus 9. Now the bottom, I'm not actually going to multiply it out. Check this out. Look at what I have in my numerator. And it matches a factor in my denominator. So I actually don't multiply out that denominator. I am ready to simplify this. And so now my simplified form is that. And so I'm going to take the limit as x goes to 9 of that. And I can plug in 9 in that case. So that gives me 1 over 3 plus 3, which is 1 over 6. Now, I told you I was going to show you a factoring way of doing this. Same kind of situation, but if we were to factor the x minus 9, so let me just a little sidebar here. Just stick it in this little box. We can actually factor this using our difference of squares. If we remember, a squared minus b squared is a minus b, a plus b. Okay? And we took the 2 and cut it in half. The powers on each of these are half of the powers that were in the original. Okay? Well, x to the 1/2 would be the square root of x. And people forget that x to the 1/2 is the square root of x. That's really important. Again, all your Math 112 is just flooding right back. And that's what makes the calculus so difficult, is that it all floods right back. And so this actually would factor into the square root of x minus 3 and the square root of x plus 3. That's what x minus 9 would be. And so if I did the problem by factoring the denominator, I would still end up with the exact same expression I had after I reduced it. So 2 options. All right. 15. Not 15. Number 6 and number 7. Here you go. You can stop the video, work these problems, and see if you get it out. These are complex fractions, and so we've got to simplify the complex fractions. All right. So both of these. Here we go. We're going to simplify the complex fractions. Now, there's a couple of different ways to do this, okay, depending on what you remember from Math 112 and how well you've done it or whatever. But I can take the numerator and actually subtract that, okay, and the denominator I can actually write as 1 over h times the numerator. I can actually make that just a 1 over h, and that makes my calculations and dealings with easier. And so I'm going to leave that out front. And then I'm going to combine these two fractions. Now, there is a shortcut to combine those fractions. X, it just depends on if you know it or not. But I called it crisscross applesauce. And so basically I'm going to do the 1 times the 5 minus the 1 times the 5 plus h all over the 5 plus h times 5. So that's putting those two fractions together. Now let's look and see what we have now. Let's do a little more simplifying. So that's going to give me 5 minus 5, which is 0, minus h. So it'll be minus h on top, 5 plus h times 5 on the bottom. Okay, so I'm going to remove this parenthesis because it's just annoying. So now, notice I can cancel now. And that's kind of why we're doing this, is trying to get it so that we can plug in the h. So that goes away, and so I have negative 1 over 5 plus h times 5, and I can plug in now. I can do the limit as h goes to 0. I can plug in 0, and I get negative 1 over 25, and I plug in 0. So again, some of this simplifying of rational expressions Some of this right here, we may need to just kind of go over that again. Just give me a holler. I'll see what we can do. Okay. Now this next one's a little more tricky, but I'm going to factor this one. And I see that I have a common factor here, so that's going to be my common denominator. This one I'm going to do, I can do slightly different, or I can do the same trick. Let's try the same trick just to see what happens. Okay, so I'm going to leave that as it was. And so I'm going to do 1 times that. So 1 times x squared minus 2x minus 2 times that one. All over those two multiplied together. Now the trick is not to multiply them out if you don't have to. So let's look at our numerator. So my numerator, but you just said you weren't going to multiply them out. Well, I'm going to multiply out my numerator. I'm not going to multiply out my denominator. Okay, so now let's look at my numerator. I've got x squared minus 4x plus 4. I can factor that. And now you see why I didn't multiply out my denominator. Yeah, now you see why I didn't multiply out my denominator. Again, I got that x minus 2 to cancel out. There we go. And I have x minus 2 over x squared minus 2x. And I can do the limit of that. I can plug in 2. I hope. Let's see. Can I plug in 2? That'll give me 0 on top. And, 0 on the bottom. Oh, I can keep factoring. Hold on. I didn't finish. Let's go back. Don't y'all love to watch me make a mistake? This factors. Let's do this factoring. We have x minus 2 over x times x minus 2. And there we go again. So I've got 1 over x. So now I can do the limit as x goes to 2 of 1 over x, and I get 1/2. Okay, so keep plugging along, keep trying. These are complex fractions on this page, and factoring and rationalizing problems on the other page. Again, like I've said more than once, this Math 112 or this pre-calculus is coming back in floods. So, hope you enjoy it. It's just math, y'all. Don't stress over it.